Hello everyone and welcome to my demo presentation for MAE 535. My name is Ronald Torres and I'll be showing you how I built a DC motor in my house. Here's a list of materials I used to create this DC motor. I used magnet wire 24AWG enamel coated for the coil. I used between 4 and 8 neodymium magnets, some scrap wood, some copper wire, a spice container, a 12-volt DC power source, some screws and washers, some alligator clips, and some superglue. The majority of the materials were sourced through Amazon, and it cost me less than $35 to make. First, let us remember the basic definition of the electromagnetic law of induction that states that when a loop of conducting wire is exposed to a changing magnetic field, a current will be induced in the wire. The faster the magnetic field changes, the greater the corresponding magnitude of the current induced in the wire. Inversely, the greater the magnitude of the current, the faster the magnetic field will want to change. Lorenz's force law teaches us that a current-carrying conductor experiences a force when placed in a magnetic field. When electric current flows through the conductor, it creates an electric field around the conductor. The field attracts or repels the magnetic field, producing a force. In this demonstration, I provided the magnetic field with the neodymium magnets, the electric field in the coil generating a current with the voltage and the wire's resistance, and a range of motion with the base assembly for this force or work to be displayed. The final assembly looked like this. A couple things to note. A commutator was needed to allow the field to be turned on and off to create the up and down motion. This part was done by modifying the copper wire in the shaft to create the on and off action of the electric field as the shaft turned. This commutator is circled in yellow in the picture to the right. One end of the coil was wired to the commutator that through the shaft was connected to the positive side of the power source. The other end of the coil was wired to the negative side of the power source. The speed of the device was measured by a tachometer app. Now here's the video of the device working. Now here's a shorter video on how I measured the RPMs. I hope you enjoyed my presentation. Thank you so much for watching.